All right, let's begin today. So, yeah, let's do a few announcements. Not these announcements. So, exam 2 will be posted sometime today. The multiple choice questions will be probably tonight at some point. It's just like exam 1, there will be 5 questions. There's about 2 recursions, 2 with files. Hello. Let's see. Etc. There's going to be one that involves classes. Yep. And then maybe 1 grid problem. So I think that makes up a good exam. Currently, everything is going to be due Friday, 11:59 p.m. Nope, there's 5 questions. Some of these are, for instance, the file class. There's files and classes merged into 1 problem. Not 6. So, this is correct. Okay. Alright. And that's basically it. So I think now we'll cover sorting as well as we can. So, I mean, Project 2, right? I'm not sure if it went well or badly. Seems to have gone relatively mixed. We did have a good number of solutions. The only problem is that a lot of people were submitting towards the deadline within the last hour. I'm just going to have to, in future semesters, this is unfortunately not a problem I can fix right now, but future semesters, we will have to force people to start way earlier. I mean, clearly something broke in the workflow. So that was, I'm glad that we got as many submissions as we did. I am extraordinarily concerned by the lateness, the fact that everything was being submitted right up until the deadline. Yeah, I mean, so for basically everybody watching this lecture, even if you're not watching it live, so if you're watching it later, I guess the only thing I want to say is, don't give up, okay? Because the course is almost over, and just don't get zeros on things, okay? Even if something's hard, even if you haven't figured out all the details, even if you need more time, whatever, just submit something, right? Submit something, because something is way better than nothing in terms of points. Like, something is something I can work with. If you're like, hey, I need help, I'm like, oh, okay. Even if your grade is low, at least you'll have something. If you submit nothing, then it's very difficult. How much does the header get you? I mean, let's not even ask that question. I mean, it's part of coding standards, right? So it's a few points. But that's not the point, right? Submit some code. Submit some real code. But yeah, don't give up. It's very easy right now. I get the feeling like people are kind of giving up, and I want to try to prevent that if it's possible. So, yep. Okay. So, yeah, the exam, I'm trying to... Well, I don't know how I'd make it closed notes, right? What's a closed note exam right now? Like, you tell me that, and then I'll tell you the answer to that question. So, okay. Alright, so let's, yeah, so the exam is generally, remember what the exam is. It's, open book, open notes, open lecture, open compiler. The thing that I would say is closed is it's closed to Chegg, other students, and that kind of thing. So, no Stack Exchange solutions, no Chegg solutions, and no collaboration. Okay? Alright. So, that's the point. Alright, so let's begin to actually talk about sorting today. So, let's do some sorting. I think, let's pull up some. Is it this one? I think it is. Okay. So before we do any major work, let's just talk about the basic names of sorts. So there's about 6 sorts that are like the basic sorting algorithms. And so what does a sorting algorithm do? So sorting takes a list and sorts it, or ensures that it is in order, meaning that if you start with the list 2, 1, 5, 6, 2, 5, you'll end up with the list excuse me, didn't even have time to get a tissue. 5, 6, right? So that's the yep, I always forget. I don't have time to wash hands right now, plus I'm stuck in a room. I'm gonna get myself sick. Okay, well, actually, here's a question. Why is the font not that? Let's see. 24, 24. Okay, what does this? Let's see. Will this go? It's not setting correctly. Maybe console font? There we are. Okay. Okay. So there's a bunch of different ways there's basically 2 classes of sorts. Let's just say, yeah, there's 2 classes of sorts. There's either the quadratic sorts, and then there's the logarithmic sorts. TAs definitely grade projects. There are 400 projects, and there's no way I can even touch them. So basically, let's start with the simplest possible sort. So let's look at bubble sort. So here's a little bubble sort visualization. And what you'll see is basically, what does bubble sort do? Bubble sort it'll compare every pair of elements, and if it's in order, it'll leave it, and if it's not in order, it'll swap it. So, for instance, here it'll compare 3 and 44. That's fine. Then it'll compare 44 and 38. It'll swap. 38 and 5. Well, actually, it'll be 44 and 5, and it'll swap. 44 and 47, it'll leave it. 47 and 15, that'll swap. But notice that it won't swap back with the 44. So if we play this out a little bit, let's play this. Algorithm, go. So what you see here is that it's going to swap there. Yep, it's going to swap here. It's going to leave, but then it's going to swap here. So you notice that it hasn't really sorted everything yet, right? 3 is in this spot. 38 has been moved. No, 38 is 38. Yeah, 38 is where it started. But 44 has been moved. 15 has been swapped. 36 is going to be swapped. 26 is going to be swapped. But you see that during any possible iteration, it's only possible to move an element by 1 in the array, right? So that's basically how far an element can move. So this is one iteration of bubble sort. And so you see that bubble sort is not really, done here. It needs to go again. And so let's go again. And so let's see. Okay, gotta swap. And so every time it comes across some elements that are out of order, it'll swap. And then here everything is in order. And what do you notice about bubble sort? Every time it goes through, how many elements are guaranteed to be sorted given this process, right? We see that 50 has ended up at the end, 48 has ended up here, 47 and 46 are already in the right places, but, we'll see how here you see that they shade in 3 of them as orange or orangish color, which means that 3 of them are guaranteed to be in the right spot. This one is in the right spot, but it doesn't know it yet. And so here we'll see that now this one's guaranteed. Even though these 2 are already in the right spot, they actually don't know it yet. So there we go, and now that one's guaranteed. And so we swap again. There we are. Swap. There we are. And then so here we see that at this point the list is actually sorted. And so this is a little optimization that they've added. What they do is they detect if there were any swaps done. If there were no swaps that were done, then they say that the sorting operation is complete. So they actually don't keep going. But theoretically, you might have to, right? So then it's just done, because it noticed that it didn't actually have to do any swapping operations. And if it doesn't have to do any swapping operations, that means that the thing is in order. So let's code up some bubble sort. So you see that here's the code for bubble sort, but it's in a kind of pseudocode language. So let's, here's the pseudocode for bubble sort. And let's delete a bunch of these lines because, so maybe I'll even post the link inside this this file here so that if anyone wants to, they can look at it. Do you need a swap function? Yes and no. So let's do it without a swap and with a swap. So here's a list. And so you notice that what it had to do here is it had to go from 1 up to the index of the last unsorted, to the last unsorted element minus 1. So of course, that is not actually computed here, if you notice. So instead what we're going to do, this is the simplest possible way to do it. We can just say for I in range len a list minus 1. So this is simple bubble sort. And then okay, so like checking if a number is the smallest added to I'm not sure. I'm not sure what you mean by basic sorting. So because there's we're going over a bunch of different sorting algorithms. So this is a basic sorting algorithm. So, and then what you do is you say, okay, for j in range, and then technically you can go all the way up even though it won't swap anything that high. And so now you want, basically what you want to do is you want to say if a list at j is bigger than a list at j plus 1, right? So basically this is saying if the thing is out of order, then what we have to do is swap it. So here I'm going to write the swap. And so there's the swap. Now we can make a helper function for this. If you want, you can make a helper function. We might do that for later. But for this one, we don't really need to. So this is basically simple bubble sort. And the reason why it's simple bubble sort is that it doesn't do any special detection. It doesn't keep track of whether it swapped anything. It just goes through the list n squared times, right? Because this will go through the list, the length of the list times, and this will go through the list, the length of the list times, well, minus 1. And then it will output the sorted list. So well, remember what happened if you just do it once, right? If you just do one random list and you just go with the bubble sort. Crap. Nope. Random. There we go. Sort. Go. So basically this is one iteration of the for loop, right? Almost. Almost there. Almost there. Done. That's one iteration of the for loop. And you see that things are shifted a little bit, but they're definitely not in the right places, right? So there's an issue here, right? Yeah, so basically there's no way for you to just go through the list once. If you only shift the things through the list once, you see that the biggest element popped up at the top, but none of the other elements are in the right place. If you go through the second round, it'll make sure that 45 is in the right spot, but will any of the other elements be in the right spot? No, because 18 still needs to be shifted back all of these places in order to get all these numbers in the right spot. So that's, what, 3 iterations? Oh wow, there's a lot of 24s there. And unfortunately, this 18 has to shift back through all of those 24s. So this algorithm, in a way, this is good because it's not going to terminate until almost the very possible end of this thing, right? Because now it has to go through and swap this, and that's all it did, but it only did one swap, but it still had to do it. One swap, and then finally it realizes that there's no swaps, but actually that was the last possible step. Well, that's what they do in this algorithm. Yeah, I mean, so that's the optimization that people do to bubble sort. So first let's test out our code here to make sure that this works. Let's write a simple bubble test. Let's generate let's import random so that we can so let's generate a random list. So my list is equal to, I don't know, let's say random.randint 0 to 100 for blank in range 100. So let's generate a list, let's print it out. How does our function work without while? Well, that's exactly what we have here. All right. So let's run the test. Nothing happened. Why? Because I didn't call this function. Wonderful. Oh, because nothing gets returned. So the A list is going to be changed. Technically, we could just call it on this and then print out my list. And remember why we can do that? Because lists are mutable, and so when we make these changes to the list, so here we are. Hopefully this did it correctly. Looks moderately correct. We can always write an isSorted test, right? Def is sorted, where we can say, and we can take in a list, and we can say, for I in range, len a list -1, if a list I is bigger than a list I plus 1, return false. This is kind of like actually like a bubble sort in a sense. This is like the inner loop from a bubble sort. And this is like the inner list from a bubble sort. So we can always just test to see if the list is sorted now. So we can print out is sorted. So that should give us true. All right. So that tests out our bubble sort a little bit. Okay. So bubble sort is a simple one. This kind of bubble sort is pretty simple, but you see that the website here and kind of the classical implementation of bubble sort uses a slight optimization, where instead of doing this, let's copy paste. And so I guess instead of simple, let's call it bubble sort MegaComplex. And so the only difference between bubble sort simple and bubble sort MegaComplex is that we change. We start, instead of doing this for loop here, we say I is equal to 0, and then we say while swap and let's make it swapped, and I is less than this thing. Now, of course, the whole point of this is that this is actually mimicking 95% of the for loop functionality, right? And of course, now we have to set swapped equals to true just to go into the loop. And then here we set swapped equals false, right? And the reason why we do this is because if we don't set swapped equal to false, then it'll just stay true forever. And then if we do a swap, we'll set swapped equals to true again. And so the point here is that we set this one just to go into the loop, right? This one makes sure that we do a swap in the internal loop, right? That's what we have to make sure about. And then this one is we actually did the swap in the internal loop, right? So this is bubble sort MegaComplex, right? So this is the optimization that bubble sort does when you have, you know, dog, there's actually a lecture going on right now. Want to come up? No? Want to come here? Want to come up? No? Okay. You're fine where you are? All right. Okay, well let's make a new test function. And of course, let me just say that the name complex bubble sort, that's a joke, right? This is not really very complex. It's just, you know, it's just not the simple version. So, okay. All right, so let's comment that one out, and let's run the complex bubble sort test. So what should the complex bubble sort test do? Well, the first thing it should do is we want to create a list. Well, so let's make up some test cases. So here's a good test case. A reverse sorted list, or a reversed list. Is this, whoops, come on. Okay, there we go. And then what we can do is call bubble sort, MegaComplex, on the reverse list. And then we want to print out the reverse list. And we want to check, and then also at the end we want to print out is sorted reverse list. Like that. And so maybe then we'll just create, oh yeah, that's a good point. So this is the one reason that you generally don't like to use while loops for this, is because, as I just did, it's very easy to forget this increment thing. So for I in range 10, so let's run 10 tests. And let's just create some random list. Let's create the list of size, say 20, and then just do this. Okay, there we go. And we can change this to 20 to make it a... So let's see what happens. And now we have to run the complex bubbles test, just to make sure that this works. There we go. So it looks like everything more or less worked, which is good. So, hey Doc J, you want to actually join in since you're hanging around? Let's actually just make this big so that we can actually look. Test 1, true. Test 2, true. Test 3, true. 4, true. 5, true. 6, true. 7, true. 8, true. 9, true. And 10, true. So, that's good news, right? What that means is that these, certainly not. Oh, yes, we are. Yes, we are, because copy-paste. Well, for this one we use the MegaComplex. For the rest of them we use the simple. The good news is it didn't change anything. Well, no, we're about to do it with recursion. We're about to. Hey, Ben. Okay, let's see if I can, hang on. Let's see. You're not audible yet because, for a number of reasons, so, let's see here. No, I don't want an input device. That. Okay, let's see if this worked.
Hello?
I think it did. You're kind of quiet. I might have to turn you up.
Okay. Yay, I'm audible. Hooray. Okay.
Oh, you were at 80%. You must have been really loud one time.
I'm generally pretty loud.
I must have turned you down because, um, yeah. Okay. So, all right, cool. So I think that's it for bubble sort. I'm bored of bubble sort. Let's do selection sort. I think selection sort is a much cooler sort anyway.
Is it? Do you think it's cooler? It doesn't have bubble in the name though.
Yeah, I think selection sort is way better. So, obviously we define selection sort way cool, and we're gonna have our standard A list. So how does selection sort work, Ben? What a pop quiz.
Oh gosh. Oh, you
Oh,
select
God.
an item
What
and
happened?
then you put it somewhere.
Oh well, thanks, Ben. That describes all sorts.
Wait, okay, so here's the thing. This is moment of candor. I always get insertion sort and selection sort confused. I think so. If you imagine a bunch of crap on a table, right? Like numbers, random numbers on a table.
I am.
Selection sort would be like looking at all of them and finding the largest one, and then setting it out to the side because you're selecting the largest one and you're putting it off to the side.
Yeah, selection sort.
And then you just keep doing that until you have all the values.
That's right.
Or you could do the lowest value. It doesn't really matter. And then insertion sort is...
Oh, I usually do the minimum, I guess. I always swap for the min on my way up.
Yeah, the minimum seems better. Because then it's like, because you want to... And then insertion sort is if you had a bunch of stuff sitting on the table, you would just grab one item and then you'd set it to the side and be like, okay, here's my sorted list. So you just grab an item and you say, 52, and you just put it to the side. And you grab another item and you 31, and then you put that in front of 52. And you grab another item, 58. Oh, that goes at the end. And then you're like, so insertion sort is kind of like you're inserting each value into your new sorted list, whereas selection sort is you select the biggest or the biggest and brightest value and put it in to your sort. So
Yep. Okay, so
let's do that.
All right, so I guess let's watch the visualization first before I do any coding.
Yeah, let's do that.
So let's click on cell for selection sort, and let's hit the go button.
Woo!
So what is it going to do first? So let's see here. Is it going to be a find min or a find max? So it's doing it my way. It's finding the minimum. So
that's good.
So what this is doing is it's going to scan through this list, and it's going to find the minimum element. Hasn't found it yet. It thinks 3 is the current minimum because it hasn't seen 2 yet. And so once it sees 2, then it'll set 2 to the minimum. There we go. Now 2 is the minimum, and at the very end, what does it do? It says, I'm at the end of the list, so now I swap whatever is here, right? Even though it's the second element, and you're like, wait, don't swap it all the way around here. It doesn't care. It'll swap it out here and swap the 2 into the first position. The good news is that you know that, you know for a fact that the first element is now in the correct position. Right? And then you just have to do that n more times, right, for the length of the list. So here you have to keep going. You know, it found 5, it thinks 5 is the minimum. Now it thinks 3 is the minimum. It sees 4, nope. Swap. Thinks 5 is the minimum again, keeps going. 4, and swap. Etc. Let's boost the speed, right? So... I guess if we're gonna meme, it's like sorting algorithm go burr, right? So.
Oh yeah, is that still? I think that meme's getting. I think that meme had a really short half-life.
No, I still see it. I still see.
Well, those people aren't on the cutting edge of.
Oh, okay. Well, I mean, the original meme was money printer go burr, right? It was like a joke on about the Federal Reserve.
Yeah, and then it was just X go burr,
yes.
Where the X is the thing that operates.
So, okay. So actually what we can do is we can write a bunch of helper functions. And you remember, I actually had you do this.
You made me do this?
No.
Oh,
I made the students do this at some point. It was practice.
201ites.
Yes, it was practice with functions. I had them do reverse selection sort, so it sorted it using selection sort, but in reverse order, not in forward order, or not in ascending order, maybe.
Yeah, descending. A bunch of 341 students on the most recent exam used the term non-decreasing.
Non-decreasing.
And I was
I
very suspicious.
I do appreciate the use of those terms because they're usually correct.
Like non-positive.
Well,
they are
yeah,
usually correct. Yeah. Yeah, but it's suspicious when a large body of people go non-decreasing.
Yeah, I'm normally suspicious. Okay, so here we're going to search from start to the length of a list. And so why are we going to do that, Ben? Why pourquoi are we going to do that?
Oh, gosh. Well, the range, that's, ooh, you put 2 arguments in there. What's that mean? Well, that means you go from the first argument up to, but not, you almost, it's like if a cat or if a kitty or a puppy, like, reaches a paw out and almost touches you, but doesn't. That's what the range second parameter does. It's
what
like,
are you talking about?
If it's 5, you go from 0 to 4. It's an almost touchy.
What? Are you all right?
Yeah, no, I'm fine.
I'm asking you, what's the start for?
Oh, what's the start
Not what's the second parameter range.
I thought it was like the whole range.
No, what's the second parameter of this function?
To say what part of the array or the list that you're interested in.
And why?
And that you're gonna. And why would we do that? Because while we're going through the selection sort, the front of it's going to be sorted, so we don't need to look at all that again.
Right, exactly.
Do I get my points? I'm worried about my grade in this class.
Well, you should be, because of the first answer. It was completely off topic.
I am worried about my grade.
So here's the cool way to do selection sort. You can do for I in range, len, a list. Haven't got to the cool part yet. Now you say min index equals find min index, a list, I. And then all you have to do is say swap a list min index.
Whoa, we didn't test it. Are we testing as we go?
We haven't even implemented the swap helper function. So So no, we haven't tested nothing. I mean, it's gonna give us a name error.
It's gonna be mad.
Yeah, it's not gonna be happy. So now at this point, let me write a helper function for swap. And so what it's gonna do is it's gonna let's take a list x and y. And what we're going to do here, the reason why it takes a list and x and y is because, remember, a list is mutable. So whatever changes I make here are going to be made permanently. So I can just do the swap here.
Did you covered mutability, right? Of course you did.
Nah. Haven't discussed it. I don't even know what it means. So I don't know why I said that word.
So the students know that if a variable is mutable, it's been featured in a 1990s children's cartoon.
Yeah, or it's like The Thing.
If it's teenaged and mutable.
Oh, teenage mutable.
Yeah, teenage mutable reference variables was a hot thing. You know, that's what got us into programming as kids.
Right.
Yeah.
So. Alright, so let's do 10 tests as usual, for no reason. They're going to be on length 20 size lists. And so here, I will now remember to change it. Selection sort test. Or no, selection sort way cool, which is the name of the function.
I'm glad you're teaching them useful variable names.
Hey now, I really don't want to hear it. Also, I agree.
Well, I mean, no, I mean, I'm only part the way. Actually, selection sort is already useful. Way cool just brings a smile to the face of someone reading it. So this is prime time. This is prime time naming here.
Yeah, so let's do selection sort test. And run it. Oh, look, it actually worked. Shocker. Cool, right?
This is amazing.
Let's do one test on selection sort. So let's show what's happening in each step. That's a good idea, right? We can print the A list. And so what we can do is after we do the test, let's make a new list. And then let's hit it with the selection sort, which is now way cool. And then let's print out the new list. And let's see what this does, right? Oh, I have an even better idea.
No. How could you have a better idea than that one?
There we go. There's no choice. You must continue, but it will ask you for an input, so it doesn't just blast through. All right, let's hit it. Continue. Yes, please. Oh, cool. Look what it did. It swapped 12 with wherever 12 came from. Let's see. 12 came from here. 54 is now here. I, Captain. And so is 28 the next element? Well, oops, it is, right? And this is actually a good test of our swap function because theoretically, you could be afraid that your swap function might accidentally overwrite something. If it's swapping with the same position. Or technically we could add a safety check here that says don't swap if I is equal to j. That's also acceptable. Okay, so now what's the next affirmative? And so 29 comes, comply with instructions. So now 32 pops out by your command. So let's see here. 12, 28, 29, 32, 38. 38 was the last one put in. And so now what's going to happen? Let's scan through this list ourselves with our eyeballs and find out what the next element is. So what's the next biggest one after 38? I see 58.
I have
54,
47.
47. 52 is not. 47, 47, 47. Right? 47 is here.
47 is like an imposter of 49. Like it, you know what I mean? Because 49 is the square of 7.
Yeah. 47 is the exit to UMBC off 95 too. Which always, and I always amuse myself because it's equal to n squared minus 2.
Where n is 7.
Where n is 7.
I was amused because I used to drive from the exit for Bel Air to UMBC, so I'd go from 74 to 47 and back.
Yeah, it could also be -7.
Oh,
that's true.
I guess it were negative. No, it would be. No, it wouldn't. Would it?
Well, -7 squared is 49 minus 2 is also 47. So.
Oh yeah.
It's the nature of. Let's go. Forward. Onward, dear friends. We're not there yet. Faith. Let's see. Say a prayer for selection sort. What else do you want to say to selection sort? You can do it. Don't give up.
Yeah. Oh, this is great. I love that you're encouraging your sort. That's wonderful.
Let's get this. We're close.
We're almost there.
Almost there.
Come on, let's flip that 84 and that 87. There. Stay on target.
Stay on target. So.
Oh, look at that. That's really sorted.
And so there we are. We're done. Selection sort worked. Wow. And so you see what it was doing. Every time it would pick the minimum element and it would put it in the next slot. Well, you see why it didn't change, right? It didn't change in these last three because here, I mean, this might have actually been an extra step. Shh, don't tell anyone. This one, on the other hand, it searched. Well, I guess technically it could have. Here it searched for 84 and it put that in the right position. So here it searched for 87 and put that in the right position. Here it searched for 96, and then who knows what it was doing here. It was, oh, I know what it was doing here. That was the last print statement there. That wasn't an extra step. I think that was just terminating. So there we go. There we are. Are we happy?
I mean, we're successful, but are we happy? I don't know. That's a pretty deep question. I'm
actually pretty happy with that.
That's not a Monday at 1:45 question, I don't think.
Well, yeah, I hear you. So, okay. Let's proceed. You know what I mean? Oh my. Let's see. Ooh. Okay. Let's do insertion sort. So, I actually have a way of thinking about insertion sort that maybe you'll like, Ben. I think of it, and I've just discovered this because I had the same problem that you did for a while. Well, actually, I didn't have the same problem. I always knew selection sort. Selection sort was burned into my brain for some reason. Insertion sort always confused the crap out of me. I'd always forget, like, what the heck do you do? How is it slightly different than in selection sort again? I forget. And I'd be like, it's kind of like bubble sort. It's kind of like selection sort. What the heck is it doing? And, I'd have to, like, look it up every time just to make sure I wasn't saying something absolute gibberish.
Yeah.
But now I know how to think about it. Insertion sort is a pullback sort.
That explains it to you.
But watch.
Pull back the pull back the curtain to see what's going on. All right.
Shut up.
I'll shut up.
Here we go.
I'll shut up.
Here we go. Ready?
Okay, here we go.
Okay. All right. So look what it's doing. It is. What is
my
it doing?
stream's buffering.
Oh no! You might have to refresh.
Oh, there we go. I got it.
What is it doing? At every stage, it's pulling the element back until it's in the correct sorted position.
Oh.
It's the pullback sort. That's what it really is. I mean, yes, it's inserting it to the correct position, but the real thing it's doing is it's pulling the elements back.
Here's another way I think about it. I like the pullback, by the way. This is fantastic.
I mean, when I thought of it, I was like,
see the hand or the like claw machine. In that game where you like claw machine in there and grab something.
Yeah, get claw machine.
Yeah, this could be like the pullback claw machine sort.
It basically is, yeah.
Instead of getting like a plushy animal at the end, you get a sorted array of integers.
Well, you get a sorted array of well-orderable objects.
Comparable items.
Comparable items that have a well-ordering on them. But you see here why this is a pullback sort, because it takes the element and it just starts swapping it backwards. And so what it really does is it's swapping these elements forward until it reaches a position where it sees 15, right? 15 is smaller than me, so I can't go back past any element. And so then it just sticks it in wherever it is. So let's make a new one, because let's see, random.
Can I lend another analogy to this?
I suppose, if you like.
So imagine you have a bag with the balls. Do they still do this where they pull the balls out for the lottery? Like they have them all jumbling around in a machine.
Yeah, they do. I think.
And then they pull. I think they still do that.
I think they.
But imagine you have one of those, and it's giving you numbers out, and then you have like a little spot in front of you where you're keeping track of the sorted ones as they come out. So each time when this pullback is happening, basically you're just grabbing the first item out of the list of unsorted stuff, and then you're gonna put it into your personally curated list of stuff that's already sorted. So it's like you're pulling just one item out of a bag and being like, "Where do you belong?" and then trying to put it into your sorted list of stuff. Powerball, yeah.
So yeah, let's just watch this again. Let's move the speed up just a little bit. So what is it gonna do? Here, nothing. Here, it's gonna pull this element back to the start. Here, nothing. Here, nothing. Here, it's going to pull it back by 1. here, 2, right?
Every time it pulls that like red thing out, you think of it, it's like that's it pulling out of the list of unsorted stuff, just pulling an item out and then sticking it into the orange area, which is the sorted area.
Yeah, but in order to do that, what do? You have to swap these elements up until it's in the right position. So basically, insertion sort could also be called swap up sort or like half bubble sort, right?
Yeah.
There's like a lot of different ways to think about it, but I think it's good because I don't know, it seems like insertion sort has also it's kind of fallen into this like void of our brains where both of us seem to have an issue remembering it.
Yeah, well, the code for them looks very similar, which is why it's creepy.
True. Okay, so let's blast the speed up, finish this visualization, and then let's code it up, because that's really the interesting thing, right? That makes life far more interesting to see it explicitly done. All right, we're happy. Maybe for the final. So, okay, let us do insertion sort. So insertion sort is currently pass. That's not right. Let's make an insertion sort. So we're gonna go, what do we do? For I in range, len, a list. And so you notice that they start at the first element, and the reason why they do that is because there's nowhere to shift the first element back to, right? So, so you start at the first element because now we're going to do a swap back. So now what we're going to do is we're going to set j is equal to I, and so now what we're going to do is swap the element at a list I back until it's in the right position. Now, by right position, I mean it's at the temporary right position, because as more elements come back, they might need to shift more. So, okay, so let's do this. What is it? What is this? So, right, we do a while loop, and so we say while a list at j is less than a list at j minus 1. And also we need to put a safety check in here while j is bigger than 0. If we don't put the extra safety check in here, well, also we might loop infinitely. There's two possibilities. Either you'll loop infinitely or you'll get an index error. Now, of course, Python will eventually give you an index error, but if you're in C++, you might actually be able to like scan past the end of the list and do some really naughty stuff. So either way,
mega naughty.
Oh yeah, no, and that's eventually like segfault land. So, so the first thing I'm going to do, because I know that someone is going to remind me, is we need to decrement this thing, and I'm going to do that first because otherwise I will forget this. And don't type in all caps. So there we go. Okay, so what we're going to do is, while this is true, actually we can use our swap function. Done. And are we finished?
Will it blend?
Good question. There's an optimization we can make to this.
Ew. We should test it though.
Ha. Dude, I don't understand what you're talking about. Like, either this works or it doesn't. It's 50-50, man. So, okay.
Sure.
Let's run the insertion sort test. Let's basically copy-paste it from the selection sort test. And so now it will become an insertion sort test. For now, let's just... I know what to do. False. The extra business here. And so then the last thing we're going to do is insertion sort onto my list. Okay, so I'm actually unsure. It's possible I've done something stupid here. I feel like this is right. Is there a problem that you obviously see? Or are you just saying test because you want to say the test?
No, just you should always test.
Oh, okay, so there's not an obvious problem. Let's run it.
Other than if false.
What is if false? No, that's in the test itself. That's just turning off this code.
I see.
Looks like it did, right? At least it sorted 10 random lists of size 20.
Excellent.
I mean,
well then
it means that it vaguely worked.
Means that we're happy. Are we happy?
I think so. I think so, right? So this is insertion sort. This is real simple, isn't it? It's very cute. Well, let's do an insertion sort way cool.
Oh, we're gonna way cool this one?
Yeah, we're gonna make a separate one that's also now it's the way cool.
And while you're setting that up, I'm gonna tell these students that if you guys show up in Professor Hamilton's or my 341 class and you haven't started testing as you go, we have a special. Some of you might not have been on campus yet, but outside of my office is a very large, it looks like a circus cannon. It's a very large cannon. And what we do is people go in there who don't test as they go, and they get blasted off to the moon. And then when they land on the moon, there's another cannon that they could travel back. But they have to complete a programming assignment while testing as they go in order to activate the cannon for their return trip. So, don't get sent to the moon. Test as you go.
Actually, never mind. Let's just mark this one as way cool, and we're done. All right. So that's the optimization I was thinking is not for this thing. So anyway, let's move on to the quickest sort imaginable. Quicksort.
It's very quick.
Hint.
It's like a quick bread. It uses soda. It uses baking powder as a leavening agent.
Oh, let's. let's not be angry with our leavening agents.
It's true.
So,
they didn't ask for this.
So I want to describe quicksort because it's pretty good. So, alright, so basically this is how quicksort works. Let's go to the visualization, because I feel like that's probably better than me saying words. Seeing is better than hearing, at least in this case.
I don't know. Quicksort's pretty terrifying, but let's watch. I feel like we should like virtually hold hands while this happens. It's a little chaos.
No, just let it run.
Bears.
Just let it run, and then I have something to say.
Okay.
Okay, it's pretty clear, right?
Yeah.
Everyone understands exactly what happened from.
Very colorful sort.
So there was no confusion about what just happened, right? And also the speed of it was not too fast.
No.
So, alright, so maybe I'll describe what's about to happen before it happens. Because that was, I think that was slightly fast. So, oh, you know what? This visualization, the quicksort, it's beautiful, but it's not great for the quicksort because it's, unfortunately what it does is the in-place quicksort. And I think the out-of-place quicksort, the or whatever, is actually better for understanding.
Yeah.
So let's think about quicksort this way.
You're not doing the dance videos?
Nah.
No.
2 buckets.
All
Okay.
right. Well, Ellie doesn't approve, so they're probably not worth it. But
you have 2 buckets, and I give you a special element. Its name is pivot. Now, why is it called the pivot? Who knows? I mean, maybe you can imagine it as some kind of fulcrum, you know, I can't spell the word now, in a, what is it? What do they call it? It's a fulcrum and a scale or a balance or a seesaw.
Seesaw?
Yeah. And so here's the rule.
I love how you didn't say lever, which is when it's mostly used.
Oh no, I completely forgot all words.
Oh, words are hard.
So the idea here is that all elements that are less than the pivot go into bucket A. All elements that are greater than the pivot go into bucket B. And then you have to decide what to do with elements equal to the pivot. And my secret selection is I create another bucket. Create bucket C and add it. And there is one good thing that doing this does, which is it prevents certain kind of worst case scenarios from happening in Quicksort. Not all of them. Some of the best and most famous worst cases still happen, but...
Do you have your drawly pad? I feel like this would be good if you doodled it out.
I do.
What do you think? You think that would be helpful? I don't know.
I'm thinking.
Yeah.
I'm thinking. Well,
you're clever, Max. So.
I guess we could. I guess we could. Sure. All right. So let's make up some numbers. 25, 30. Well, that's 40.
No, that's a real number. That's not made up.
1 plus I.
3.
67 and 91. All right.
20
and then first we have to delete 1 plus I. So, whoops. Where'd I go? Where'd I go just now? There we are. So basically.
Whoa, that was some magic. This software, amazing. Look at that.
Yeah.
You're a wizard.
Yeah, it goes from there to even. Blah, wee. So, okay, how do we quicksort? So we quicksort by taking this first element. We call this one the pivot. And then we look at the rest of the stuff and we say, you, my friend, are less than the pivot. So you go into bucket A. I don't know why I picked a red background at some point, but I did. And
ooh, that's very handsome. I like that color.
Yeah.
That's a. Oh, we don't get to keep it?
No, just because otherwise I'd have to do a bunch of... I'd rather be transparent so that...
Yeah, no, I get it.
Yeah. Okay, bucket B.
Yes, this is great. I love this bucketry.
And so 41 is bigger, so it goes into bucket B. 3, well, what the heck? Don't skip 56. Bucket B. Bucket A. Bucket B. And bucket B. All right. So now what you do, and here's the trick.
Oh yeah, 20. But yeah, sorry.
25 stays as the. So this is the classical one without the bucket C, because there's no element that's equal to the pivot. All the elements are distinct. So, all right. So this is stage 1 of quicksort, and so what you're gonna do after this is you're going to basically recursively call it. So now you're going to call the sorting algorithm on this, and so now 22 is the pivot, and 3 goes into this bucket A, right? But this bucket A is much smaller, and this bucket A, B doesn't really exist, right? Or it exists, but it's small. And then here, I don't remember which order these were in, so I'm just going to throw them in random order here. 56, 67. And so now, if 41 is the pivot, we're going to do some more bucket sorting. 3 is in the other side. So 41's the pivot. And you notice here we're actually getting a worst case because everything goes into the second bucket, right?
Oh, that's so sad. You don't want an empty bucket.
Yeah, so then we're going to do it again. Only this time, let's say 56 is the pivot. Actually, no, let's say 67 is the pivot. The only reason why I want to make 67 as the pivot is just so that we get clean buckets.
You want some crisp bucketry.
I know I'm kind of inventing which order they were in, but guess what? I'm allowed to do that. So
you have incredible power, and we should all respect that.
Well, I mean, yes.
Don't be modest. Incredible power. I mean, look
And
what
so-
you're doing with all these rectangles. You can't be stopped.
No, basically I can't.
Yeah.
And then, wait, is this recursion? Oh, it couldn't be recursion. It just absolutely could not be. Yeah, it definitely is recursion.
It's super recursion.
This is definitely recursion. Let's see. Can I spell recursion? Not really. So,
Beautiful.
okay, so now how do we put all this back together, right? So basically, now when we're popping out of the R word, we, You're welcome, Ben. Sorry, your laughing is getting to... Okay. So when we're popping out of here, we join anything in this bucket with the 22, and then with anything in this bucket. So basically we got 3 and 22, and then there's nothing over here. And then we put this one on, 25. And then we say, okay, now what? So now we have 41. 41. And
Whoa.
I'm leaving room to indicate that there could be stuff over here, but there isn't. And then I'm going to put 67 over here. Again, leaving room to indicate that there might be stuff on both sides. And then you stick 56 into here because it's less than that, and you stick 91 on this side. And then you would leave this recursion and collapse. And then you would leave this recursion and collapse. And then finally, now that you've done this side, you've done this side, you've done both sides of the recursion. And the list is relatively sorted.
And so overall, you're just saying, I want to sort bucket A, and then after I get those things, I want to put my pivot in, and then I want to sort bucket B and put that in as the end.
That's
so
right.
It's sorted bucket A, then the pivot, then sorted bucket B. And then we could do the real mind-blowing thing here and say that the whole time we might have already been in someone else's bucket. Like there might have been a larger list being sorted above us.
Oh,
we don't
okay,
even
I understand.
know.
I was like, what are you saying?
It's oh my gosh, that's like when you realize that the world outside the Matrix is another Matrix for another world outside that Matrix. And then you realize you're watching movies that got disingenuous as they went on. But anyway, yeah.
Yeah, actually, it kind of depends on your opinion about like so you know they don't take that simulation thing. Like, do we live in a simulation? It's like, what's the probability that a species develops simulation generating properties versus the probability that you're living in a simulation of another species that has already generated those simulation generating qualities.
Wow, you turned a fun movie into like something that you could
No,
derive a
but
confidence
as you
interval
say-
for.
As you said, the question that has not been asked is, what is the probability that we live in an infinite descent of simulations? So there is actually no original simulation. There is just always we're just living in a simulation above, you know.
So it's, I think, therefore, there is some amount of simulations.
Right, there
simulating
exists
that process.
some simulation in which we live, but then the problem is that the same property applies to the people who've generated our simulation.
Wow.
So,
I think you just took Descartes to lunch, or maybe brunch. Maybe you didn't take him to lunch. Certainly didn't take him to dinner, but maybe lunch or brunch. Wow.
Cool. So, the point is that in any recursion you need a base case. My base case is going to be this. If the length of the list is less than or equal to 1, we just return the list. The reason is because if it's empty, then we return an empty list. If it's just a singleton element, we don't really have anything to do, right? So now I'm going to be classical.
Ooh.
Assigning the pivot to be a list 0. And now I'm going to create 3 buckets. So bucket less equals empty list. Bucket greater equals empty list. Bucket equal equals empty list. Now you can always just throw in all the equal stuff into the greater bucket. The only problem with that is that you have to be careful not to also throw the pivot in. If you throw the pivot into the greater bucket, then you will end up quick sorting recursively on the same exact bucket again and again and again and again. And so that's why I make an equal bucket, because I'm like, if you're going to do something special with the pivot, why not do something special with all possible things that are equal to the pivot and just simplify life?
It sounded like a cheesy, like, Valentine's Day commercial. Why not do something special with the pivot? Why not? Sounds good.
You know what? We can even use a for whatever this is called.
Or thing in other thing.
Yeah, it's a
X
for each
X X X X. Ugh.
What's the problem with X?
I mean, it's a perfectly viable letter.
I mean, my hope is that it seems perfectly meaningless, right?
Okay. It is pretty meaningless.
Nope, it's not a function. Okay. So here we're done almost, right? Well, sometimes, I will say this, sometimes it is good to have a symbol that conveys no meaning. The reason is because then it indicates to the reader that the meaning is not in that symbol, right? X is a perfectly indistinct thing from a list.
Their hand gestures here are adding incredible value, by the way.
You're welcome.
Excellent.
So, read the comment. So, okay, so here comes the recursive step. Get ready. And so, do we need to quick sort the bucket equal? The answer is no, right? Because bucket equal is all equal to the pivot, and then we quick sort, and that's it. Well, then I delete that line.
So, this is actually pretty simple.
Is it?
I might venture to say. I mean, look at it. That's not a lot of code. There's none of this, like, swapping. It's not... I'm not scared. I mean, there's recursion happening, but whatever. You know, whatever.
No, these students are new and improved. You don't understand. They love recursion now.
Oh. Yeah. Yeah.
So...
Or they fear decrying it. Either way.
No, they cursed classes. They say that classes are hard, they hate them, and they hate me for assigning them, and they hate even the fact that Bjarne Strostrup made C++ with the feature of the class, and I mean, just literally curse be to all things. But on the other hand, they say recursion is great. So let's do a quicksort test. Right, and that will probably complete our day. To quote the Odyssey, so ends the bloody business of the day. I did that particularly for you. I hope you know that. I wouldn't have done that was it not for you being here to laugh at it.
It just made me think you should help people write their wedding vows or something.
Yes, I take you to be my lawfully wedded wife. until death, dismemberment, or some other accident of that manner. All right, let's run the test and see how badly it does. Ooh, it failed. It failed.
I will
What happened?
continue to love you through the following disfigurements. Okay. Oh.
It failed.
Oh, we
It
failed.
failed.
Oh no.
Hang on. It failed.
What happened?
Oh, I know why it failed. Because, we didn't actually assign it to that. So it was not the quicksort that failed us. It was the test that failed us. Because remember, in all the other tests, in all the other sorts, the list we were doing swap operations on a mutable list. So I didn't need to return it. I didn't need to save the list. It was just already modified. For this one, you see that I'm creating new lists, and I'm adding those new lists together. So the original list is unmodified. And so this was just a little reminder that, as it turns out, mutability matters. All right, let's run the test again and see how badly I screwed up in real life. Oh, look, it didn't fail. I like, so I prefer to say things in the sense like, instead of it succeeded, I prefer to say it did not fail. Because it makes me feel a little bit, yeah, is sorted is just a little function that runs through the list and checks if the thing is sorted. All right. So, what did we learn on the show today, Ben?
Gosh, we learned about the R word, and
if you guys don't know, right? Let's hope that this doesn't get my lecture banned.
Wait, what?
What did we learn on the show tonight, Greg?
I think you've just been cut off. Oh. Yes! Oh, from the best talk show host ever, don't at us.
Yeah.
Don't at us.
So,
Greg Ferguson.
So yeah, look at all these tests. They worked. So we learned to test our code sometimes. We learned bubble sort.
We learned about the moon cannon. So if you hear either of us say, we're sending you to the moon because you haven't tested, you'll know that that's the cannon. So if you come to our office and we say, well, what did it do when you ran it, and you say, well, I haven't run it yet, it's cannon time. We're not mad. Look, we're not upset with you. It's not, we're not any of that stuff.
Oh, I'm
it just
upset.
It just means it's time for your trip to the moon via a cannon. That's all. That's all it means.
Right. So we learned bubble, selection, insertion, and quick. We didn't learn merge. We'll do that Wednesday. Let's see here. Is that it?
You're coming down the home stretch of 201 here.
Yeah, we're about to do. I've shortened it, so we're only doing one short day of Big O stuff.
Yeah.
And I'm gonna mix it in with merge sort. So we're gonna do announcements, merge sort, and then probably have a little bit of time for Big O next time. And then that's all I'm gonna say about algorithmic analysis. And we're not gonna. The secret is I'm not gonna test it very hard. Don't tell anyone.
Don't tell anyone. Okay. Yes.
Okay. Yeah. Don't tell anyone.
The thing is, we want you guys to see it now, so that you're like, hey, ooh, that's a thing, and then so that when you see it in 341, you're like, ooh, I have a memory. But yeah, you don't.
I'd like to
we
find
don't have time to
I'd like to
fully
find
teach
a
it.
good way to teach it, but I admit fully the inherent quandaries and vicissitudes of the,
Well, I think when students are working on the recursion project, it's hard to jam much more sophisticated stuff into their brain goop because they're recursion saturated.
Yeah, they don't know about that yet. That starts next week.
Oh, so that's why they still love recursion.
Yeah.
Oh, I mean, look, it is lovable. Don't get me wrong. I love recursion. But as I say, when you start 341, you will ask, do
Yeah,
we
every-
have to use
every
recursion?
project's
And
a
by the
recursion
end, you'll
pro-
say, can we use recursion? So it's a useful tool.
Yeah, every project is a recursion project in 341. I think that's more or less true.
Something, or at least feels that hard.
Yeah, Project 3 is going to be recursion. You know, as is the ancient tradition.
Yes.
Um,
Passed on to us by our forebears.
yeah,
We had 5 bears. It's a dumb joke, but it never.
I am going to ban you for that. That is. I mean, there's certain things I can forgive, and there's certain things that will stay with us forever.
I just imagine 4 really old bears. Okay. I don't know about you.
Go ahead. What do you got? What do you need?
But yeah, it's I'm getting punchier as this semester goes. How about you? Are we wait, hold on. Should we go to the darkness? We should release people from their thinking useful information is about to come.
It's done. Let's see. Are you audible again? Say something. Oh, you're not audible right now. Hang on. We'll go back to here, and then we'll turn off all the video. And I don't know, we're gonna turn this off. Maybe that. Okay. So now it is just us, I think.
Whew. All right. This is comfortable. It's cool in here when it's this dark.
Yeah.
Yeah.
Feels good.
Mm-hmm. Yeah. It's really, there's a lot of like brightness before. Yeah. Anyway. So yeah, are you feeling a little punchy? I'm feeling a little punchy. There's only so much talking alone in my room to myself that I can do, or to my cat.
It's a very strange experience.
It's a strange experience.
I think for the people who have showed up to our lectures dependably, our loyalists, our our few, our merry few, our band
of
brothers,
irregulars. Yes.
For he who watches this lecture with me today shall be my brother. And
or sister, or whatever, or
no, you can't.
Because Jules watched.
There's only so many modifications you can make to old Bill S. So.
Oh yeah, that's true.
Right. I mean, I'm quoting from the Battle of Agincourt in Henry V.
Yeah, of course.
So.
Your stream's still on. We know. We're in the darkness. It's calming, cooling. But yeah, you guys can go. You don't have to listen to us talk. We didn't get good points for there's some Neil Patrick Harris.
Yeah.
Some NPH goodness. Yeah. Anyway.
I'll admit that this semester has had its ups, but it's had more downs.
It's had ups? Oh, I wasn't there for those. What happened? There was an up?
Well, we had 409 submissions for the project yesterday. I was not expecting to even crack 400. I was very happy.
Oh.
It seems like perhaps my execution will be delayed. Yeah, I mean, just imagine if I had to, not pass over half of people. I would be so sad. I would be like, no, we cannot. Oh God. My fear was very high yesterday. My anxiety level was so high I couldn't even write their exam, which is quote unquote due today, right? At least due for me. So I'm going to have to finish that. They don't know it, but I'm trying to write an easy exam for them.
They don't. Oh, okay.
They don't know
That's
it.
between us. That's between us. So if you give them a really hard exam, they'll know that you failed miserably.
Yeah, if I fail, then the exam will be difficult. If the exam is easy, then I have succeeded.
Excellent.
It's hard to know because you know, what one loves, another one scorns, kind of thing. You know, it's one of those types of situations in life. What will the final be like? It is undetermined at this point, but almost certainly it's going to be like exam 1 and 2. Yeah, this semester has definitely had some interest. I think the problem is we have turned into email response bots.
Yeah, that's true. I do
feel,
spend a lot of time doing that.
I do openly feel like my job is no longer teaching. Teaching is something I love. This hour is a break. This is like a vacation from my job.
This is a nice vacation. Yeah.
These little lectures are my solace from the rest of what I have to do, which is usually pretty hard. Or not hard, but garbage. And that's the thing about it. And I never really conceptualized how much I was like, oh, student in-person interactions are so superior to email interactions. I always knew this, but
it's a fact.
But like,
factuation.
Yeah.
Yeah. All right. Well, I think we should release everybody. What do you say?
Are you gonna do that? Or okay? I mean, I'll go
so.
and do
I think
my job.
I need to go. I've been, as you know, wrestling with some health issues.
Oh yeah, are you still messed up?
Still pretty messed up, and I think I need a nap. But I did a bunch. I wrote the 341 students. They were really excited for homework 4. They kept saying, "Where's homework 4? I'm just so excited to do more homeworks," and I didn't want to let them down. So I wrote them a homework 4.
It didn't disappoint.
And I hope I didn't disappoint. Yeah.
4.5 stars on Yelp.
They're artisanally crafted homeworks by hand.
Yeah.
I take my computer science knowledge, free range computer science knowledge, and then I lovingly scrape off the bits that don't make any sense.
Well, you know what the difficulty is with anything in teaching is there's like difficulty times like inherent interestingness of the problem. And you want to optimize this product, right? You want to kind of minimize the difficulty while increasing the interestingness of the problem.
And the learning, the challenge. You want it to be challenging, but not like needlessly difficult.
Right. And
all the difficulty should cause learning to happen.
I think I wish I could optimize that better. I think that's my goal in life.
Oh, it's hard. It's hard.
Yeah, to figure out how to make more interesting, but also less problems that don't involve so much prerequisite garbage before you can get to the part that the nougat core of the candy bar problem.
Yeah.
You know? Anyway, I'll let you go so that you can nap. And I'm going to let myself go so I can finish writing this exam.
Yeah, people don't need to listen to us complain. They've got their own things to complain about.
Oh, do they?
Like, oh yeah, everything's awful. Oh, right. Oh, I'm sorry. You know, I don't know if anyone... oh, gosh. So, I meant to tell you. I forgot. I feel really bad about this. And I guess I'll just tell everyone else that's here as well. But everything sucks. Yeah, I'm sorry, I forgot. So now you know everything sucks, and you know you can kind of keep going. I mean, you're Eric Hamilton. You wield incredible power, so it may not touch you as deeply. But
great
yeah,
and terrible.
Great and terrible. Yes, great and terrible. I have to wonder, of the 27 people, how many of them are just sleeping? The people still allegedly watching.
There's at least half of them who are drifting in and out.
They're sleeping, or they're like playing a video game, and they're like, "Wait, is this learning anymore?"
Well, no, but hey, I would watch a video game and listen to a live stream. I mean,
yeah.
I listen to Joe Rogan and play games or whatever. You know, that's a 3-hour. That's a 3-hour commitment.
He's a commitment. I love it. Some of your students think that I'm one of the TAs, which I kind of love. Because they'll get to 341 and be like, oh, wait a minute. This guy, good for him. He's not just a TA anymore. They're letting him teach classes. I really hope that happens. Oh, Eric, here's another cool thing from teaching online. I learned, I saw some students or somebody talking somewhere, and because none of the students are like have seen us in person, especially with your freshmen, like some students say that like they've watched their professors on stream or on YouTube or something, and then they meet them in person and they have this weird kind of like they feel like they're meeting a celebrity even though they know it's just their college professor. So that'll be weird for everybody when we all go back in person. They'll be like, oh my gosh, there he is. That Professor Hamilton, he is as handsome as YouTube makes him out to be. Except I won't have my cat. I'll probably get a lot of stuff from that. So
yeah, I mean, you're gonna have to like almost bring them in, or whatever. Maybe Char.
Students you really think will remember you? Fair play.
Hey, I remember a great degree of my college professors. I remember a lot of them.
Yeah, I remember at least 2, and I work with some of them now.
Wow.
I work with some of them. I work with probably about 4 of the professors I have, and I remembered at least 2 of them. No, I'm kidding.
I remember let's see, do I remember 202, 203? I remember 341, of course, because we both had Edelman different times.
Oh, such a good professor.
I remember 411 because I had Squire. Who's still here, I think, right?
He is.
Or is it the different Squire? Yeah. And then
everyone throws around legend, but he's an actual legend.
Yeah, I mean he's.
I had Dr. Chang, and now and Professor Oates. Very good.
Yeah.
Awesome professor.
See, I mean.
Yeah.
So. I mean, I remember, and that's just CS. I mean, I remember most of my math professors too, though. A number of them have retired.
I'm bummed because this semester for 341, oh gosh, some of your TAs are 341 students and they'll be upset when they hear this, but I was gonna do binary search trees with frisbees outside. So and we should do this together whenever we're back in person. What we do, get some frisbees.
Yeah.
I don't know how we're gonna get these frisbees, but get like 30 some frisbees.
Yeah.
And we write numbers on them in Sharpies. And then we just stand there with our bag of frisbees and we have the students all spread out in the field and we throw a frisbee to one student who's now the root of the binary search tree.
Okay.
And then they have to do all the balancing procedures.
I get it.
Via frisbee. And what's beautiful about this is that usually when you do the binary search tree stuff, you can see the whole tree, and so our human like, oh, I see that it's unbalanced. But when you're spread out in a field, you can only really see the people adjacent to you. And so I think that would help people really cement. And boy, would that be ever memorable. Remember that time we played Frisbee to learn binary search trees? Oh!
Yeah, not bad. Not a bad idea, in fact. That's very artistic and creative.
It's very artistic and creative and an excuse to not do a boring lecture with a PowerPoint. I will go to extreme lengths. I will try to secure funding so that I can give a lecture without having to write a PowerPoint.
Yeah, I'm thinking.
I can get rid of a PowerPoint.
So this semester, I've used some PowerPoints, but I basically like skimmed through 3 or 4 slides and then just not use the rest of them. I think it's been mostly positive. Maybe people hate it. Maybe people prefer it to be more structured, but I think it's better without. I always hated PowerPoint. You know how much I hated PowerPoint before I came here.
Yeah, we're both. We hate PowerPoint.
I made all those Google slides, which are essentially PowerPoint, and then I used them for the first year, and then I kind of hated them, but I kind of thought that they were decent, and then they're good reference material, I think, but they're not. I think someone reading off of, especially online, someone reading off of slides is like, that's nap time. Right, that's
super nap time.
I mean, you're not gonna.
PPT stands for probably prohibits teaching. I don't know if you knew that.
I certainly did not know that, but I mean, I don't believe that it's conducive to the learning environment. You know.
Oh my! You should teach in that voice the whole time. I thought it might be hard to maintain.
Yeah, I think I would default back.
Yeah, or you get that kind of nose blindness that you get, where it's like, ooh, a funny voice. Because some students were like, you should do a whole lecture as like the Macho Man Randy Savage, and I was like, that would be fun for exactly 23 seconds, and then it would be, I would get a respiratory infection, and everyone else would just be bored of it by the end. But yeah, ew. Anyway,
Yeah, well, I mean, maybe I'll cancel my 341 lecture, and we can join if it's all in person. Well, this would also be a good social distancing activity. So if we went back hybrid over the summer and the fall or whatever, we could actually do that.
yeah, that'd be amazing. Even
if
so socially distant,
even with social distancing, because throwing the frisbee is you're apart.
You are. I don't. I'm upset because I'm gonna have all these students that I don't know what they look like, and they'll be like, "Oh, you're Jeff. Oh, excellent. You're quite the memester, Jeff." But yeah.
Yeah. The one thing I will say about balancing trees is, and I mean, this is my only defense of red black. I think AVL is probably just a better thing overall. I think
I didn't do red black this semester.
Really?
Struck it because we did so much with splay trees, and they actually had to implement one. I was like, eh.
I think the only real defense of red black, and this is the reason why I kind of like it, is because the only balancing feature is dependent on local things that the node can see around it, right?
Mm-hmm.
And not based on something like height, which is a global feature of the entire subtree, right?
That's true.
The red-black tree doesn't have to know anything about anything else except for parents, uncles, children. That's it. And so that's my defense of it. You know, I was talking with Marin at one point, and I explained to him, I was like, the reason why I like red-black better is because it's dependent on local topology of the tree.
Mm.
And he's
yeah,
like,
you math people.
And he's like, yeah, I get that. Like,
he also is on board for if he ever teaches a 341 section. He's also on board with the frisbee activity. I bet we could get some other professors in on it. Ooh, we could have like 100 people in a field. It'd be amazing.
Well, yeah, and we could insert a whole bunch of nodes.
There'd be so much data. Oh,
I know.
So much data!
What we'd have to do, I think, is do some prep. We'd have to print out, like, sheets of paper with big numbers on them, so that we could be like, that person is wearing 51, that person is wearing 27, right?
Oh no, it would be on the frisbee.
Oh.
Frisbee.
Well, but then once that last insertion happens, you need a person to hold that value.
Right.
Yeah, so they would then, oh, you mean we have 100 frisbees?
Yeah.
No, you have one frisbee, and you have 100 sheets of paper.
Oh, no, 100 frisbees. Go big.
Okay, if you can get the department to splurge on 100 frisbees, then...
my Amazon does not know
let's check.
who I am or what my interests are. My Amazon, I have scoured the internet for bulk frisbee purchases. I figure we might be able to go to the rack and get some frisbees or something.
Okay.
Anyway, we gotta make this frisbee.
I think it's better to get like a few high quality frisbees, and just
come on. No, we want some crap frisbees. The problem is when you buy frisbees online, they're really sketchy about how big the frisbees are. Like, you really gotta, like, look hard to find the frisbee diameter. Because they'll be like, you can get 50 frisbees for $20. And you have to really dig. Because they'll even show you pictures, but unless there's, like, someone holding the frisbee, you don't have any...
I kind of see that.
I don't want to get,
this one is a 200-gram frisbee, but...
Right, it's like, yeah, cool, but how big is that?
But 200 grams is only the mass.
Oh, yeah, this is good. JC.serial number, we might be able to kind of like swoop in to like the bookstore and be like, hey, you got any extra frisbees? We promise we won't put permanent marker numbers on them, and then we will. No, we wouldn't do that. That would be lying. But yeah.
You know they're never the bookstore is never going to release a single
No,
Frisbee
my
to you.
reputation precedes the crap out
No,
of
they
me.
wouldn't release it to
So
anyone.
No one's gonna let me do anything.
No, you'll walk in and be like, "Can I have 20 Frisbees?" They'll be like, "Sure." Each one costs $20, so $400, please. And you'll be like, "I'm a professor. Can I get a discount?" They'll be like, $600, please.
They'll be like, which professor? Professor Johnson? No, we heard about you. Deal's off. We don't even
Right.
want to be a part of your. We don't even want to be. We don't even want to be accountable for selling
whatever you're gonna
these to
do.
you.
Yeah, whatever you're gonna do with those Frisbees, we know it's not gonna be good. So
Mm-hmm.
yeah, we're out. I'm sorry. It's like a
Yeah. Not since the incident. Right.
hey, no one was technically killed.
No one was killed. No one was killed. Thankfully.
I mean,
Some of them, they certainly, it's not their fondest memory, I'm sure. All right, which incident? You know,
we can't
the
talk
incident.
about it, unfortunately.
Yeah, we can't.
There's
talk
legal
about
restrictions.
The incident.
We're
Yeah,
barred
the
from
incident. Yeah, we can't talk about the incident. Definitely happened, maybe, but it didn't. Definitely.
You have the best hedges.
Oh, that's true. Well, that's from doing like corporate software development. It's all about expectation management. We'll
No,
definitely get you that software maybe by sometime eventually.
Picard, of course.
Oh, It depends on my situation, right? If it's just to be buddies with, Picard all the way. But if I'm gonna be in some sort of rough and tumble
With an
exploration
alien lizard.
mission, yeah, or with like
A Gorn.
yeah.
Yeah.
I wanna. We were starting to watch the original Star Trek from the beginning.
Yeah.
And there's like in the first 4 episodes, there's 2 cases where there's like women with mistaken identities. I was like, I'm glad this show got off the ground because it looked like they were already scraping the bottom of the writing barrel like 3 episodes in.
There are a lot of strange. So yeah, there's a lot of strange episodes of the original series that don't get repeated even on like syndication anymore. Like even when they're like, "Oh, it's a throwback Thursday. We're watching original series Star Trek." You don't see them, and there's a reason. They weren't all winners.
Sometimes there's a stinker.
I mean,
And it's not even like some shows you go back and you watch and you're like, "Ew, this doesn't hold up well."
Oh
It's
no!
not
So
that.
there was a next gen there was a next gen episode where Beverly Crusher kind of has a little love affair with this quantum ghost thing. It was possibly one of the worst episodes of TNG, but it was such an an awful like use. They were like, let's give Beverly Crusher a story.
Hold up. The students are talking about watching stuff for English 100. I
Yeah,
wonder
they're-
what it would take for us to get to teach an English 100. You think they'd let us do that?
So actually, I was looking around and I noticed that the math department doesn't offer topology. That's what I want to do.
Oh,
I
okay.
want to teach a topology class. But if we could joint teach English 100, that would possibly be the most.
God.
It would be English 100 cross-listed as like an AI 471, cross-listed as topology 430 in the math department.
No, I think it would be like yeah. Or we could probably come up with some sort of writing. Well, there is a writing class. There's 304, which is like yeah.
Yeah, indeed.
Yeah.
Indubitably.
All right. I've promised that I'm gonna go. I've worked my diet back up to proteins. I'm very excited.
Oh God.
I was at simple carbohydrates, and I'm up to proteins. It's very nice. Anyway, well, everybody have a lovely day and test as you go. God, test as you go. And yeah. All right. Bye, Eric. Bye, humans.
All right, everyone. That's it. Show's over.
Get out of here.